your app keep restarting again, again and again. No traffic, no stability, logs repeating the same error. And Kubernetes, it keeps restarting your app as if that will fix it. This is called CrashLoopBackOff. And in production, this can silently kill your application. Hi, I'm Shivam and this is the first video of Kubernetes debugging series. Let me show you why this happens and how to fix it. So in the previous videos, we learnt about how Kubernetes runs your application. But now we are stepping into real production problems. What happens when your app starts but fails immediately? Kubernetes will restart it again, again and again until you see crash loop backoff error. Let's break this on my local kind cluster. Before we get started, I have one small request. If you have been finding these videos helpful, I did really appreciate you subscribing to my channel. It's a simple way to support my work and it encourages me to keep creating more contents like this. Now let's jump into the video. So this is my local kind cluster. I have one control plane node and two worker nodes. Now let's simulate a real world issue. An application that starts but fails because a required config file is missing. I have already written the YAML configuration for a pod. Let's check that. So as we can see, the kind is pod. The name of the pod is crash demo. It is using a busybox image and it is using some commands and arguments. Let's go over this one by one. So this command sh-c, this is a very important command. This overrides the container's default startup behavior. Sh means run a shell and -c means execute a command string. This tells Kubernetes run a shell and execute whatever comes next. Then we have couple of arguments. This first line args : it tells that this is the actual command that will be passed to the shell. One important concept to note here is command is the entry point and arguments is the arguments to the command. So here sh-c will execute everything inside args. This symbol means multi-line string in YAML. So instead of writing one long command, I have written multiple lines of command. This echo starting application simulates application startup. It just prints a message so that it can be logged into the log file. I again have another echo statement which says connecting to required dependency, and the reason why I have written this is again to log this message into our log file. Now the third line simulates a real production issue. It says a config file is missing. This is exactly the kind of error you would see in a production logs. And the final argument is exit1. So it clearly explains failure. So there are two options for exit. If it is exit 0, it means success. And if it is exit 1, it means it's a failure. Now since we have gone over our pod.yaml file, let's apply it and we'll see the outcome. I'll do a kubectl get pods. If you see here, the current status of the pod is crash loop backoff and it has restarted once. Let's monitor this for some time. We can again see the status is error and the pod has restarted again. Again, the pod went into error and it restarted. So this is a loop. So the Kubernetes starts the container, the application inside it fails, the container exit and Kubernetes restarted again, again and again. This is crash loop backoff error. Now I'm gonna exit out of this. Let me clear the screen. Let's debug this properly. I'll do a describe on the pod first. So let me grab the pod name and let's do a describe on this pod. Oops, I gave the wrong pod name. Okay, let's scroll down to the events and we can clearly see that image was successfully pulled. Kubernetes tried to start the container, but Kubernetes failed and we got backoff restarting failed container error. So here, Kubernetes is trying, but it's failing. Now let me clear the screen and we will look at logs. And the name of the pod is crash demo. We can clearly see this error that a config file which is required is missing. This is a real production problem. So, what is crash loop backoff? It means your application is crashing and Kubernetes keeps restarting it. But after repeated failures, Kubernetes slows down the restart attempts. That's the backoff. So, Kubernetes have a restart behavior. Fast restarts initially, then delay the increase, which prevent resource wastage. By default, there is a restart policy in Kubernetes which is always set to restart policy equal to always flag, which means if a container exits, restart it. This usually happens in production environment when a config file is missing or a database is not reachable or an app crashes on startup or a dependency fails. In our case, it was a missing config file. Now let's try to fix our pod properly. We will provide the missing config file using a config map. So let me clear the screen. I have already written the config.fix.yaml file for our pod. Let's check that first. So this is the first part where the kind is config, the name of the config is app_config, and it has defined some variables or configurations inside the data section. And below this, we have our pod. The name of the pod is crash demo. It is using a busybox image. And this is where we are providing our commands and arguments. And I am mounting this config map as a volume to our pod. So let's go over this one by one. So these are just two echo statements which prints the message for our log file. The third statement is cat app/config.yaml. Here, the application is reading the config file from /app/config.yaml. If this file exists, the app can start properly. Again, I am printing the message application started successfully for the logs, and then I have sleep 3600, which means our application will sleep for 6 minutes. This keeps the container running because in Kubernetes, if the process stops, the container stops. Now let's take a look at our volume and volume mounts. Volume mounts, it means that this is where we attach external data into the container. This mount path equal to /app means we are mounting the data inside the container at the location or directory equal to /app. So anything inside this volume will appear in the folder /app. Then I have defined volumes, which is the actual data storage. This config map name equal to app_config is the name of our config map what we have defined here. So we are using a config map named app_config as the source. That config map contains our config file. So we are mounting a config map as a file inside the container, and now the app can read it and start successfully. Earlier, the app failed because our config was missing. Now Kubernetes provides it and our app will run successfully. Let's apply this new pod and we will see what happens. So let me clear the screen and I will apply this file. Oh, before applying this file, let me delete our previous pod. Okay, our pod has been deleted. Let's apply our config.fix.yaml. So it says our pod has been created. Let's check our pod. It says our pod is now running and we do not have any restarts. So what changed now? Before, app failed instantly. Container exited and Kubernetes keeps restarting our app. But now our config file is present, app has started successfully and there is no restart. So here is a simple rule. If your app exits, it's a restart loop, and if your app runs, it's a stable system. In production, this is very common. This happens when a config file is missing, or a secret is not mounted, or a database is not reachable, or an API dependency fails. And once, if any of the above mentioned happens, the application never stabilizes, users see downtime, and traffic fails. Crash loop doesn't always alert you immediately, but they destroy availability silently. So, now you understand something critical. CrashLoopBackOff is not a problem. It's a signal that your application is failing and Kubernetes is just reacting. If your app exits once, Kubernetes will restart it forever. So now you have seen what happens when your application starts but crashes. But here is a deeper problem. What if your container never even starts? No logs, no application, nothing running inside it. You will see a strange state, container creating. Kubernetes is doing a lot of work before your app even starts, pulling images, mounting volumes, loading secrets. And if anything breaks, your pod gets stuck. In the next video, I will show you exactly what Kubernetes is waiting for and why your pod gets stuck in container creating state. That's where real debugging begins. I will see you in the next one. Till then, keep learning.